Okay, so today we're going to start Forces Unit 3. And this is going to take us pretty much all the way up until right before Christmas break. So this first week, we're going to focus on 8.6a, TEAC 8.6a, which is Balanced and Unbalanced Forces. This is a power presentation that you're going to go through and listen to and answer any notes that you have. This is the sheet that you should have in front of you. Some of you may have it where there's blanks to fill in, and some may not. Okay, some of them may have it filled in for you. If it's filled in for you, make sure that you are following along and you're at least circling or writing notes, highlighting something, whatever it is that we're talking about that time. Okay, these are going to go in your journal so that you can have them for resources in the future as needed. So let's begin, shall we? All right, balanced, unbalanced forces. Ultimately, this is what your sheet will look like. This is a colored version of what you have in front of you. So let's get started. I'm going to write on the one with the blanks. So if you have one, you should be writing what I write. All right, let's get started. Force is a push or pull of an object. Okay, so all forces is just me pushing a piece of paper to you or pulling one back. Let's say I'm sliding you a piece of paper, I'm pushing it towards you, I am applying force to that paper. If I'm pulling it back towards me, then I'm pulling it, and again, I'm applying force to it. Otherwise, it's just sitting there on the table all by itself. Force is measured in newtons. And for example, you have 1 newton, the 1 N equals 1 kilogram times mass. I'm not times mass. I'm sorry. 1 kilograms times meters per second squared. So 1 newton equals, so on your paper, I want you to write 1. Oops. And then N. 1 N equals 1 kilometer. Oh my goodness. I am so messed up. Go back. 1 newton equals 1 kilogram times meters per second squared. That's how you read that. 1 kilogram times meters per square second. Per second squared. Jeez. All right, so now when forces are balanced, there is either, so right there you should say on your paper, looking at your paper, when forces are balanced, you want to write balanced, there is either no motion or constant motion. All right, so if you are on the paper where you're not writing these, you should at least be circling the words that are looking like they're in different font, okay? All right, so what this means is when forces are balanced. So a balanced force is just one that's either got no motion or it's constant. Right now, that pen is in balanced force. There's no motion, right? Constant motion looks like if the car is going down the road on cruise control, and say it's at 60 miles an hour, and it's staying at 60 miles an hour, that is also called a balanced force. It is traveling at the same speed, okay? So remember, balance can be perfectly still or moving at the exact same speed. Balanced forces do not cause change in motion. Okay, remember, this is a balanced force if it's moving, okay? It's not going this way because then it would be unbalanced. And besides, what would make it go this way? A different force, okay? So balanced forces do not cause change in motion. Or this is a balanced force, and it's still not causing a change in motion. The forces are equal. Look at your example here. You've got two guys playing tug of war. Does it look like in the picture anyone is winning? No. It looks like no one's losing. It looks like they have the exact same strength that they're pulling on that rope at the exact same time. Therefore, that is a balanced force. Okay. If he let go of it, then it would become unbalanced and this guy would fall. Balanced. All right, now we're going to look at unbalanced forces. So now you're on the far right side of your chart here. So you're going to write where it says forces can, you're going to put unbalanced forces can be in the same direction or in opposite directions. Now I'm going to move this over here just so it's out of the way. All right, so now look at this picture. Okay, you've got this dog and this boy walking this dog. Who's pulling the dog? Or who's pulling the boy? Or who's walking who? Really and truly is what we should say. Who's walking who? Well, the dog is technically walking the boy because he's taken off, right? And we've all walked a dog or seen someone struggle walking a dog because the dog is exerting that much more force, right? When forces are unbalanced, there is a change in motion. So look at your worksheet. When forces are unbalanced, there is a change in motion. Okay. Again, I'm standing, my pen is sitting still, right? Balanced. Now it's unbalanced. I just forced it to move. The forces are not equal, right? If this is staying still, that's a balanced force. If I'm pushing it, it's no longer balanced, right? It's not equal. I just came along and moved it. Unbalanced, unequal, unbalanced. Now we're into the center, okay, of our paper. Blank force is the blank of, okay, I'm reading on the paper. So now look at the screen. Net force is the sum of all forces acting on an object. Let's look at some examples. Okay, you have a cake sitting on top of a table. Would you say this is balanced or unbalanced? Balanced, right? The cake is sitting on the table at 2 newtons. The force coming up, holding it in place, is also 2 newtons. That's why they're balanced. They're equal. The way you write it is 2 newtons minus 2 newtons equals 0 newtons. Okay? All right, look at this one. Moving in opposite directions, we subtract. Now, we have to do a little math, okay? But here's how you find out if it's what the newtons are of the force. We're going to start with unbalanced first. Unbalanced is moving in opposite directions, you subtract. So when you have a force, like look at your picture. You've got a little boy, right? He's arm wrestling a big giant man. Well, the little boy is exerting 3 newtons of force. Big guy is doing 6 newtons of force. Aren't they going in opposite directions? One's trying to make his arm go one way, the other one's trying to make his arm go the other way, right? So they're in opposite directions. So we call this unbalanced, right? And how we write it out is 6 newtons minus 3 newtons equals 3 newtons, okay? 3 newtons. So if you're unbalanced, if it's going opposite directions, you always subtract. You might want to highlight that. or something. If it's moving in the same direction, you're going to add. Look at the two horses. Because think about it. If the two horses are causing work, right? They are unbalanced, but still they're moving in the same direction, right? Then you add them together. So one horse is the 6 newtons. Another horse has got 8 newtons. You put them together and you've got 14 newtons. Remember, if you're moving in the same direction, you add them. If you're moving opposite directions, you subtract. So here I'm going to put 6 in my little square here, my little box here, plus 8n equals 14 newtons. All right. Oops, sorry. And there's a thing down here you cannot see. Let me hide this real quick. Oh, go back. All right, so forces always occur in pairs. This is the part I want you to see. At the very bottom, put forces always occur in pairs. All right. This is just a quick cheat sheet to help you. So your sheet should be filled out. You may color it as you like, but definitely I want you to glue it in your journal, okay? And call it Balanced and Unbalanced Forces. All right, thanks.